Hey everybody, welcome to the official episode 1 of our Pi Piper model P116U. You'll see that we have the radio out of the chassis and, doing an inspection, and I've noticed a few things here that I want to cover with you. First thing you need to know is right here on this tuning condenser, there's a spring that you got to be careful you don't lose. I've put a piece of tape here just to make sure it doesn't go anywhere for the time being. And you can see that we've got a couple of problems going on here, which I'm going to cover. This capacitor, which is a 0.01 capacitor at 1,000 volts, was just kind of hanging in the breeze here. And I'll explain a little bit about what happened there. But let's dive in and take a look at the circuit board. So first of all, this is a circuit board. It's a primitive circuit board. Anyway, it's a primitive circuit board in the fact that it's not really a modern one that we would use today, and I'll show you what that looks like. And there's some inherent risks with working on this thing because of that. So this is an early adaptation of circuitry, I guess. So there's no point-to-point wiring here. So let's okay. Sorry about that. We're back. So first thing I notice is down here. I have to, before I show you that, I want to talk about something. So when our good friend Phil told me about this radio, he was very, very careful to say several times, keep an eye out for the Hunt's capacitors. And I had no idea what he meant by Hunt's capacitors. Being Italian, the first thing I thought he meant was this.
California grows about 98% of the tomatoes in the country, and it's a big deal here.
Then I realized that couldn't be it. Then I remembered that this radio comes from England, so I thought maybe it was this.
Good afternoon, ladies and gentlemen. Here we are at that famous little town of Gravy-on-the-Vest, about to bring you the annual fox hunt. The next voice you hear will be that of Lord Throttlebottom. Are the hunters ready? Tally-ho! Are the dogs ready?
We're ready.
Get on your marks. Get set. Go!
But alas, lo and behold, that's not what he was referring to. He was referring to a brand of capacitor, apparently made in the UK, that is known to be bad and have failures. So we're going to show you what that looks like right here. We're going to zoom in really close so you can get a feel for what our friend Phil was talking about when he said watch those Hunt capacitors. So we're going to turn this around right here, and I believe if I position this light just right, we should be able to zoom in there. Let's move this just a little bit. Got to get our focus. And you can barely make out the writing right there where it says Hunts. And I'll point it out for you. And let's get our pointer. Okay, here's our pointer. Right here, it says Hunts. And you may not be able to see it very well, but it's split open. Let's see if we can turn it around at this angle. Maybe you could see a little better. You probably can, right there. You could see that thing is basically split open, and it looks like its guts have started to come out. That's not good. So now I know what a Hunt's capacitor is. But upon further inspection, taking a look a little further down, I find this mess. At first I thought it was a bug, but you know what that is? It's another Hunt's capacitor. So my theory here, and if you look you'll see lots of charring and stuff all over this circuit board. So I believe that we've had a flame out in this thing. At some point someone plugged it in, it wasn't in pretty healthy shape, and it did a little bit of a flame out. So let's get this camera up. Okay, so that brings me to this area right here. Let's zoom back just a tiny little bit. Okay, so this area of the circuit board right here is where a capacitor goes. It's this one right here. It's a brand let's see, TOC? I don't know. 0.01, 1000 volts DC, working volts, I guess. A type 204. And if you look on the side here, they didn't put wax on these. The ones in the US that we're used to, they usually filled these ends with wax. Not this one. And you can see it's corroded and it's probably leaky. Same thing on this end. Not in good shape. So when I took the radio out of the chassis, this end of the capacitor was already disconnected. This end was connected, this end was disconnected, and this chassis was full of caked on flame out, just like I showed you on that Hunts capacitor. So I had the opportunity while the cap was out to clean the board. All right, and I used a little bit of rubbing alcohol, a little bit of elbow grease, and you could see here that this board is clean and it's actually almost restored. However, we had a little problem. So we had the lead sticking out of here that was going to this capacitor. And as I was cleaning it, this thing was kind of spinning. And I said, that's weird. How could that be? Well, I'll show you how it could be. So let's take a look at the bottom of this board. This is what I want to show you. This is important stuff. Okay, let's put something to prop this up. Right here. And you heard me mention that this was a primitive circuit board. And you'll see, basically, it's just a piece of phenolic material, I would imagine, that has traces attached to it. They're probably adhesive traces, probably some type of adhesive tape that are attached to it. And there's holes drilled for the components. Well, this is where that capacitor was. Let's zoom in on that so you could see it. Right there. And when I flipped it over to look, the actual trace had broken off here, and the trace was spinning in circles along with the lead. So I've already repaired it. I've put it back down, and I've soldered it to this trace, and we're good. I put a little bit of flux on it, and we're good. But that tells me I'm going to have to be really careful with this board. Now, one other thing that I've noticed on this board, we'll zoom back a little bit, is if you look in this area, it may be a little bit hard to see on the camera, but there's wax on this bottom of this board. Okay, and you could see here that this board is heated up at some point. This is the tube socket, and it's probably gotten really, really hot for probably when it did a flame out, and the wax melts. Now, why would they put wax on the bottom of a board? Well, that's simple. Protects these traces, right? They even tell you in the documentation that if you're going to remove a component, to scrape the wax away. So that's what they did, is they put in some type of beeswax or other type of wax, I'm not sure if there's a special kind for this, to protect the circuit board. And you'll see we've got a lot of mess here. It's really a mess, and I'm going to need to figure out how I'm going to clean it. That's not a big deal. We also have a mess on the other side. So this has been repaired, and we'll get to that much later in the series. But I do want to show you, if I have any other broken type of traces, I want to show you how I'm going to fix it. So let me stop the camera and we'll come back and do that. Okay, so here's how we're gonna tackle this board if we run into problems. When I first started in this hobby about 5 years ago, I bought this tape. It's called Tape Master, and it's 3/8 inch, 55 yards copper adhesive, conductive adhesive. And you'll see here, it's really nothing but copper tape. Alright, so if we end up having a bad trace, or we break a trace or something, I can easily take this and trim it, and reapply it to this board, and fix it. And it'll probably be better than new, because it has a good adhesive on the bottom. I'm not sure what kind of adhesive they used in the 50s, but here's a piece that I've cut off, and I can cut it to just about any size, and you'll see it's very thin, and it's solderable. You can put solder on it, and I can fix just about any trace. So I'm covered there. I'm not worried if the board gets damaged. I have a way to fix it. But I've made a command decision on this radio, and the reason why I'm doing that is because I have two of these. So Phil sent me two radios. This was the better one of the two. If you recall, the first one I showed you in episode 1 had been submerged or covered in water at some point, and the circuit board itself is really dirty. This one's really dirty too, but it's not as bad as the other one. So here's how we're going to attack this radio. All right, there we are, back over. Now you'll see it's point-to-point wiring. I mean, it's not point-to-point wiring, which makes this really simple. All I would have to do is remove these 3 red wires that go to this tuning capacitor. The 3 red wires, actually the 2 red wires that go to the on-off switch. And there's a couple of wires here that go to the band switch. All right, I can easily relocate them. Easy, piece of cake. And I should be able to remove all these other components. Remove this metal shield, remove the switches. And I should be able to clean this board. And I'm going to do that because I've proven that with a little bit of elbow grease and a little bit of time, I can restore the board back to new. And I just don't feel comfortable restoring a radio that looks like this, because I don't know if there's carbon traces here. I don't know if it's conductive. I just don't know. I'm not going to take any chances. So we're going to take our time. There's not a lot of components. I have another radio to refer to if I get in trouble, but this is so simple I don't think that'll happen. And I'm going to restore this entire board as much as I can, working around these tuning cans. I'm going to restuff the electrolytic right here and put it back on. And we're going to get this board looking brand new by the time we're done. We're also going to clean up the metal on the tuning cap right here. And we're going to clean up this piece of metal here, which has a little bit of rust on it. And this is what holds the tuning and controls. There's also a bracket that goes from here to here, which kind of keeps this thing steady. It had rust on it. I already have it soaking in the evaporust, so we're going to get that nice and clean. So our next step in this radio is going to be to remove all the components, do a thorough cleaning, being very careful not to move components around too much because I'll break the traces on the other side of the board. Once we clean it, we're then going to replace all the components that need to be replaced, and there's quite a few here. So we already know about the Hunts capacitors. There's a couple of resistors down there that look really, really old. And there's a bunch of other stuff here that probably is out of tolerance that we're going to change. And I also notice right here, let's zoom in so you can see it. This component right here, this little wafer, that looks to me like it's a couplet, which is an integrated circuit, an early integrated circuit. And if we look at the parts list, let's see if we can find it. Looks like it's identified as part number 9. Let's see what that is. No, that's not a couplet. It's actually a 510 puff mica cap. Looked like a couplet to me, so disregard that. It's not an integrated circuit. It's just a mica cap. So we're going to go through all this stuff and get this stuff in much better, cleaner condition. And then we put it back together, and I think we're going to be good. So take a good look at it now. You'll see how dirty it is in there. It's all going to look like this when we're done. See how clean that is? I've already scraped back to there and cleaned up. On the bottom, we're not going to be able to do as much because I don't want to disturb these traces. I will clean as much as I can around these tube sockets in case there's any carbon. I'll test for conductivity. I'll test the traces. But I'm not going to be able to do much on the bottom here, and that's okay. Matter of fact, I may put another layer of wax on here when I'm done. I'll have to think about that. But that's further down the road. There's another electrolytic right here. This is a dual 50-50 right here at 275 to 350 working volts. So there's really not much left to do, or I should say there's not much to do on this thing except for clean it. I can always replace these wires, and we're going to be in very good shape. So that's the plan, okay? So I'll end this video here because I'm not going to make this into a half-hour video. I just wanted to explain to you the plan of attack and what we need to look at and be careful for on this radio. So with that, I will end this episode, and in the next episode you will see this thing completely taken apart, and you'll see the cleaning process, and we'll start to replace some of the components. Until then, I hope everybody has a really good weekend. And I'll leave you with this before we say goodbye.
Let's maybe speak next week. Yeah, okay, I'll give you a call.
Oh, this has been so great. Thank you, sir. I'll see you soon. Yeah.
Well, listen, have a great weekend. No, you too, have a brilliant weekend.
No. Yeah, 100%. Will you send me that email and then yeah. Oh, thank you.